1 to infinity. See, this pen's writing good now. I just had to break off that dried up crust on it. All right, in this one we have cosine of 1 over k minus cosine of 1 over k plus 1. So, write out the first 3 terms, then plus dot dot dot, and then write the nth terms. Show all your cancellations and get a formula for, well, S sub n equals, write out the first 3 terms, plus dot dot dot, plus the nth term, cancel out whatever cancels, and then find the limit as n goes to infinity of S of n. So everything that we did in the previous example, give it a try. A little carried away with the parentheses, but do you agree with that? And then negative cosine of half, positive cosine of half, subtract out. 1/3 subtract out. This cosine of 1/4 will subtract out with the next one. All of these in between will cancel out. The last one will cancel out with the first one there. And we're left with cosine of 1 in the front minus cosine of 1 over n. I'm sorry, 1 over n plus 1. That's what we're left with. That work for you? All right. Now, when we find the limit as n goes to infinity of S of n, we're finding the limit as n goes to infinity of that. Cosine 1 minus cosine of 1 over n plus 1. So cosine of 1 is a constant, that sticks. 1 over n plus 1, what's that going to approach as n increases without bound? 0, so we're going to get minus cosine of 0. What is cosine of 0? 1. Sine of 0 is 0. Cosine of 0 is 1. Cosine is the x coordinate on the unit circle. So if you go out 0, the x coordinate there is 1. So we have cosine of 1 minus 1. Let me see if that's how they left it here. Yep. If you put it in a calculator, you get approximately negative 0.46. But I would probably be happy right there. Any questions there? All right, we're going to do one more of these, and we're going to cut it more of these. Maybe I'll pull up the PowerPoint slide. Just one more of these though. notice how these have all been given to us? A term minus a term, right? Every single one of them. Oh, I've only done two. But it's been a term minus a term, correct? Well, wait till you see this next one. Now, we have the sum as k goes from 3 to infinity. Of 4 over 4k minus 3 times 4k plus 1. All right, we have two issues here. One issue is it does not start at 1. Now, we could probably work it starting at 3, but it's nice if it starts at 1. So we're going to make an adjustment for that. The second issue is that's not written as a difference. Remember the previous examples had one term minus another term? To be telescoping, it has to be a term minus a term. This isn't going to be telescoping here.
Do we split them apart? We do 4 and then 4k minus 3 and then 4 divided by 4k plus 1. How'd that work? Do we split them apart?
Yes, we split them apart, but not the way you said. Does that make sense? Yes, we split them apart. What process do we know that would split that apart? I did it last Sunday. Partial fractions, yes. We have to do partial fraction decomposition to split them apart. Does that make sense? All right, now, if we let, write it over here, I'll be erasing this, but if we let j equal k minus 2, okay? We're going to let j equal k minus 2. That implies, if you solve it for k, that k equals j plus 2, right? Just add 2 to each side to get j by itself, or to get k by itself. Is that okay? So, this is scratch paper work over here. So if we put j plus 2 where this k is and write it in terms of j, so we get j plus 2 equals 3 to infinity. I just substituted that in place of k here, 4 over. Now we're going to substitute it in for these k's, 4 times j plus 2 minus 3 times 4 times j plus 2 plus 1. Let me confirm in my notes that I'm doing this correct. Yes, I am. Well, if we subtract 2 from each side here, we got j equals 1 to infinity. And then over here, distribute the 4 and simplify. So that'll be 4j. 4 times j is 4j. 4 times 2 is 8. 8 minus that 3 is 5. Are you guys okay with that? Simplify this in here. 4 times j is 4j. 4 times 2 is 8. 8 minus 3 is 5. Is that okay? Now we're going to do the same thing here. 4j. 4 times 2 is 8. 8 plus 1 is 9. okay?
The reason why we did that, like j equals k minus 2 is because we're trying to make it into, the k equals 1, is it?
We want the sum to begin at 1. That's the whole reason for that. All right, so this is equivalent to, now, this was scratch paper work and I used J. Does it matter what letter we use?
No.
Then I'm gonna use K again, just because I like writing K. That's the only reason, there's no math reason. K equals 1 to infinity of this. 4 over 4K plus 5 times 4K plus 9. Let me think a second here. 9 times 13 is 90, and 27 is 117. Yeah, see, look what happens. I'm gonna erase this. Yes?
We just leave it to J.
Could we leave it in J?
Yeah.
Yes, you could. Yes, you could. But watch what happens here. If we put in 3 for K, we get, I'm gonna be erasing this, but we get 4 over, 4 times 3 is 12, minus 3 is 9. 4 times 3 is 12, plus 1 is 13. Now over here, if we put in 1 for K, we get 4 over, 4 times 1 is 4, plus 5 is 9. 4 times 1 is 4, plus 9 is 13. Do you see that those are the same? So we just re-indexed, and it's gonna generate the exact same series.
So how does it make it easier to bring it to, k to equal 1 than it is equals?
Let's see how this plays out after we do the limit, okay? There might not be an answer to that. There might not be. I got it here in my notes. I don't have that answer in my notes, but I got this problem all worked out here. But, yeah, there might not be an answer to that. All right, now, let's, we gotta get this split up into 2 terms that have minus in there, have a difference. So let's do our partial fraction decomposition. It's already factored for us. So we're gonna have 4 over 4K plus 5 times 4K plus 9 equals A over 4K plus 5 plus B over 4K plus 9. All right, we're going to multiply through by this denominator. And here, both factors cancel out. Here, the plus 5s cancel out. We have A times 4K plus 9. B, and then plus 9s cancel. 4K plus 5. What could we let K be that would make this 0? -1, 4 times -1, -4 plus 5 is 1. We need it to add up to 0. Okay, if it's not obvious, set it equal to 0 and solve. So it's going to be -5/4. Subtract 5, divide by 4. If it's not obvious, set it equal to 0 and solve. So we're gonna let k equal -5/4. That will give us 4 equals a times 4 times -5/4 plus 9 plus b, what's that gonna be? 0. We just found the value of k that makes that 0, so that's gonna be 0. Now here, the 4's divide out, and we have -5 plus 9 is 4. Divide by 4, and a is gonna equal 1. You guys all right with that? So we're gonna be putting 1 here. Now, we need a value of k that makes this 0. Anybody know what it's gonna be?
It's gonna be negative 9 divided by 4.
-9/4. Just in your head, set that equal to 0. Subtract 9, divide by 4, and you got -9/4. What I just said was this. 4k plus 9 equals 0. Subtract 9, divide by 4, we get -9/4. So k equals -9/4 will give us 4 equals, that'll be a times 0 plus b times 4 times -9/4 plus 5. So that is, a times 0 is 0, so that's gone. Here, the 4's divide out. We have -9 plus 5 is -4. Divide, and b will equal -1. So now we can rewrite this sum as a is +1, so 1 over 4k plus 5, minus, because it's -1, 1 over 4k plus 9. Okay, all of that was to, doctor it up so we could do what we did in the previous 2 examples. Now we're where we started on the previous 2 examples. That's where we started on those. That make sense? Any questions about what we've done here? As far as this part goes, we want that to be a 1, so we want to put a j plus 2 here, so that when we subtract 2, that becomes a 1. So, all right, let's continue. So now we're like we were in the previous examples. S of n will be 1 over, so now we're putting in 1 rather than 3. So Daniel, yes. We're putting, when we do this step now, we're starting at 1 rather than 3. So I think it just makes this computation make more sense. I don't know.
Or is it just because that it's,
Because we re-indexed.
Okay. I'm just curious how it worked out. Just,
If we did here, it'd work out the same. Yeah.
Is it just more complicated numbers?
It's not the norm.
because
It's not the
subtraction
norm.
instead of a, multiplication.
This is number 59 in the book, this example.
So if I could avoid the decomposition.
I'll have, I think, no, you can't avoid the partial fraction
Oh,
decomposition.
that part, but the other part we.
The reindex.
This, you could probably,
Could we have done that without that?
I think you could avoid this. but you'd be doing that with these terms, not with these.
Yeah.
Okay? All right, let's go ahead and finish this. So when we put in 1, we get 4 times 1 is 4, minus 3 is negative 2, no, I'm sorry.
Now we're going off of this.
Over here, I messed up here. 4 times 1 is 4, plus 5 is 9, so we're gonna get 1/9 minus 4 times 1 is 4, plus 9 is 13, 1/13. Now we're putting in 2, that'll be 8 plus 5 is 13, minus, that'll be 8 plus 9 is 1/17. Now we're putting in 3, 12 plus 5 is 17. 12 plus 9 is 21. I'm running out of space here. Plus, plus, put in n, and we get 1 over 4n plus 5 minus 1 over 4n plus 9. And we see that the 1/13 subtract out, the 1/17 subtract out, that 1 over 21 will subtract out with the next one there. Everything in between will subtract out. The last one will subtract out with this one, and we're left with the 1/9 in the beginning minus 1 over 4n plus 9. So now, the limit
Did you say that?
as n goes to infinity of s of n, so the limit of this, which is that, equals the limit as n goes to infinity of 1/9 minus 1 over 4n plus 9, which is going to be 1/9 minus 0, which is 1/9. So the sum of all infinitely many terms is 1/9.
What did you say cancels out the second to the last term? What cancels that out?
So you see in
That-
each group here, the second term cancels the first one.
Yeah, I see that.
Second term cancels the first. Second term will cancel the first one here.
Okay.
That's gonna happen with all these in between.
Okay.
The second term cancels the first,
Okay.
and you're left with that one, and it's minus.
Okay.
Is that okay? That's telescoping series. There should be an S on the end of this. There we go. Time we got. And that's as much as I'm gonna do with telescoping series. Okay? That'll be the hardest case scenario there, I believe.
Sure.
All right? Now,